In Algebra 2, Section 3.5, we're dealing with operation of matrices. Matrices is a way to organize data. Sometimes we'll use data like in tables in order to create the information matrices. Sometimes we'll even use matrices to help us solve systems of equations, especially with 3 variables, because you saw how long it took us to do those problems. But before we can do that, we're going to take baby steps. And so there's different properties and operations you can do with matrices and rules. The first thing is called a scalar multiplication. And basically, when you multiply a matrix by a constant, that means everything in the matrix, every position is multiplied by the same constant. And that's how you multiply a matrix. When you add and subtract matrices, it's pretty simple. You just find its corresponding part. So if it's in, let me explain. So if I have A, B, C, D, F, G, H. So if I have 2 matrices that I'm adding or subtracting, I do A plus E, because this is row 1, this is my row 1, row 2, column 1, column 2. So because A is row 1, column 1, E is also row 1, column 1, so that's what I add, the corresponding parts. C is row 2, column 1, so it's row 2, column 1 is G. And then B plus F and D plus H. And that's how I add and subtract, just its corresponding parts. In order for this to happen, though, a rule is they have to have the same dimensions. They have to have the same number of rows as there are columns. So this is 2 row by 2 column. This is 2 row by 2 column. That's why I can add them. If this had an extra column or row, then I would have missing corresponding parts, and I couldn't do that. So the rule is you add or subtract the corresponding values, and then it has to have the same dimension. So for example, number 1 wants us to find A plus B. So we have A plus B would be, this would be row, this is a 2 by 2, row 1, row 2, column 1, column 2. I have to check if this has the same number of rows and columns, row 1, row 2, column 1, column 2. So after I check this, once this is checked, then I can add them with corresponding parts. So row 1, column 1 would be 6 plus minus 3. It would be row 2, column 2. So it looks like this. This would be row 1, column 1, row 2, column 2, row 1, column 2. So this is column 1. And this would be row 2, column 2, right? Because our answer has to be our answer has to equal the same dimensions as our A and B. So what this means is I have row 1, column 1, so 6 plus negative 3. Then I have row 2, column 1, so negative 1, row 2, column 1, which is plus 0. Then I have row 1, column 1, which is 4, and then row 1, column 2, which is 4 plus 1, and then 0 plus 3. And then I just add them together. So 6 plus negative 3 is 3, negative 1 plus 0 is negative 1, 4 plus 1 is 5, 0 plus 3 is 3. Now I know I might have made it a little complicated putting this, but when we start multiplying and all that sort of stuff, it's very important to know how to do this, to know how to do the key so that I can read it. So basically I know that my answer dimension has to be the same. So that means I have to have 2 rows and 1 column. So just like this, I have row 1, row 2, column 1, column 2. And so I just match it. This is row 1, column 1, okay? Row 2, column 1, row 1, column 2, and that's how I come up with these variables. Once I have these, then I just go ahead and plug in its corresponding parts, add them together, and that's how I got that, right? My next one, they want me to subtract A from B, and here I have row 1, row 2, then column 1, column 2, column 3. This one I have row 1, row 2, but I only have column 1 and column 2. Because they are the same dimensions, I can't add or subtract. I can't do anything because they're not the same dimensions, so this is no solution. Okay? Because, one more time, they're not the same dimensions. I have an extra column here than this, so then by the time I get to column 3, I have no corresponding parts to add, or subtract. So go ahead and write this down. I have a few more examples. So this one is if A equals this, find 2A. So this is what we call scalar multiplication. And scalar multiplication is easier than adding or subtracting. Basically, I'm just doing 2A, so I'm doing 2 times everything in here. 2, 1, negative 1, 3, 0, 5. This one, it doesn't matter what the dimension is because I'm only multiplying the one matrix. And I'm multiplying everything by 2. So 2 times 2, negative 1 times 2, 0 times 2, 1 times 2, 3 times 2, and 5 times 2. This gives me 4, negative 2, 0, 1, 6, and 10. And this is my scalar multiple. Basically, my scalar multiple is 2 times bigger than my original matrix. Okay? Okay? All right. Next, they're making us asking us to do a combination. So they want us to multiply each of these and then subtract them from each other. So what I'm going to do is I'm going to focus, before I subtract, just like order of operation, multiplication comes first. Before I subtract, I'm going to focus on this and this. So I'm going to first do 4A, which is 2 times 4, negative 1 times 4, 3 times 4, and 0 times 4, which gives me 8, negative 4, 12, and 0. Right? Now I'm going to also find 3B, which is everything on B multiplied. So multiplied by 3, negative 2 times 3, 0 times 3, 1 times 3, negative 1 times 3, which gives me negative 6, 0, 3, and negative 3. Now I can subtract, okay? We broke it down. It's just, a combination of the same, different problems in one problem. So if we break it down, it becomes easier. Now before I subtract, I have to check, are they the same dimension? Well, 2 rows, 2 columns. 2 rows, 2 columns. Perfect. So now I'm going to do 8, 12. I have to make sure I put it in order. This asks for 4A to come first, so I have to put that first. It does matter, just like in regular equations, which comes first when it comes to subtraction. Okay, now I'm going to do 8 minus negative 6, negative 4. It's good to do this. This is how you show your work. Minus 0 is out so that you can see. This helps avoid make mistakes because these problems that we're dealing with this chapter are very long. So whatever you can do to minimize math mistakes, like the small addition and subtraction, would be great. Okay? And even then, I still make mistakes, as you've seen in my videos. We do 12 minus 3, and then 0 minus negative 3, which gives 8 minus a negative, which is 8 plus 6, which is 14. Negative 4 minus 0 is negative 4. 12 minus 3 is 9. And what is this? 0 minus this is my end result. Again, these are not difficult concepts. It's just you have to make sure to break it down. Go ahead and try page 175, numbers 5 and 10. 175, numbers 5 and 10. And this is the last video in this outfit, so no more mini. Anyways, I'll see you in class.